I'm going to be talking about how you can bring some ease into your integration testing for AWS apps. I guess since you're all here, are you using AWS? Okay, good. Okay, there's some delay here. Okay, that's great. So, you know my name. Ironically, I transitioned from local tech to Postman about 1 month ago. I'm no longer a developer advocate, but I'm still their #1 fan. So, as you can see, if you want to reach out to me and talk about this, I'm still in contact with them and we can still geek out. Otherwise, you can reach me. That's my handle on social media or on LinkedIn. We can connect. So, let's talk about testing. And the first thing I want to discuss is that some things cannot just easily be tested. And this feels like a bit of an anecdote that people tell at parties, so that if NASA can make a mistake, it's okay for you to make mistakes. Maybe you're familiar with the Mars Climate Orbiter. You know about that? Okay. In the 90s, NASA basically sent a space probe on the surface of Mars to observe the atmosphere. And they had a bit of a mishap. It was supposed to enter a bit higher than planned. So when the probe approached, they had to do a course correction, and the probe had thrusters for that. And the problem was that there were two software components. One was developed by Lockheed Martin, and that one was using freedom units for the impulse of the thruster, which was pound-per-feet per second instead of Newton per second, which was the unit expected by NASA. So obviously the calculations for the course correction were off by a factor of 4.45. And you can see from this diagram that instead of entering at 226 kilometers, it crashed being so close to the surface of Mars. So they took responsibility for it, and they admitted that the problem was that basically they didn't do integration testing properly, even though the components worked individually in their own. And that ended up costing them a lot of money. I guess in today's, adjusted for inflation, that's 571 million just for some components, and then 300, and then another 160 million. I don't know. I get paid in acorns compared to this. It's a lot of money. So what's the first thing we take away from all of this? Is that integration testing is important. And the second thing is that it must be realistic, because numbers were concrete, but the measuring units were not as expected in reality. So we always have to factor in some reality, but how realistic should our testing be? And the truth is, we've gotten very used to being fake. And I'm talking about tests and at work. I don't care what you do in your personal life. But we just got very adapted to using test data, or we used Selenium to simulate the user that we thought would be delayed. They pulled it about the testing. In terms of stamina, we didn't really account for memory leaks of our applications. So we always had version test. Scaling, I don't think that was accounted for as well, because it was always like single fastest web server. So you get the gist of it. And then sometimes you have no choice, and it's fine, and you can come up your tests. But I wanted to tell you a little story about my previous job in development, where we had to integrate a lot of services. And we had a consultant come in who was challenging us a lot. He didn't tell us what to do. He was just asking a lot of questions. And he also gave us a lot of resources to help us with figuring out how to do clean code and integration testing. So part of the inspiration for this talk are the code cop, as we called him, and another talk that is more than 10 years old, but I think is still valid today. It was called To Mock or Not to Walk. And eventually we ended up with tests that looked like this, because we thought mocking was the greatest thing ever. This is Java, by the way. We used a Java framework the behavior of our APIs. So we created a stub and we defined the behavior for every little API, and we were expecting the interaction to be as we defined it. So how do we move this to our applications that have dependencies in the cloud? Particularly AWS. This will revolve around AWS. And the thing is, we want to keep things as real as possible, and we want to make sure that our components interact with each other as expected, or as we want, obviously. And the truth is, we a lot of us have switched to just using the AWS environment for our tests, and the reality comes with a pretty long checklist that looks something like this. So you need to create a separate account. You have to have the separate environment with dedicated variables, databases, for example, secrets. You need to make sure that your data is isolated, the services are isolated. You also need to make sure that you always clean up your resources. So you don't leave them running overnight and obviously spike costs. Maybe you want to integrate them with your CI pipeline. You need to account for permissions, logging, all different stuff. Yeah, maybe you want to work this in parallel. You need to make sure how to handle persistent versus ephemeral resources. And it's a lot of work for that, obviously. And some things are complicated. It's just the way they are. So when it comes to testing, I think a lot of us are guilty of sort of practices, at least at some point in our lives. There's a method that's called Let's Prove It Works, where you focus on quick end-to-end testing and you mock only the necessary things. And it looks something like this, where you have a happy flow, you avoid all the bugs, you work on mock data, and the reality of QA testing is that it will come back with complaints. And then there's another method called mocking the boundaries. You're not concerned with anything else that doesn't belong to you. So when you mock remote systems and you reuse those mocks a lot, for example, we did that. We abstracted them into separate libraries to the point where if something changed, everything was tangled and not working out great. So we need to circle back to reality. And the truth is that using real AWS resources is expensive. Just from my personal experience, I was trying out some stuff. And one day I got a $10 bill. So it adds up. And we want to keep things on a budget. So sure, mocks are great. They take up some time. So that's what it means that you pay for them in a different way. And also maintaining those mocks. So maybe that's not the way to go with them. That's more pixelated than I thought, or it works for my computer. So mocking usually carries the risk that if the service that you're mocking gets updated, you have to keep up with that. So you take on that responsibility of doing the research, making sure that it still behaves as expected, that nothing that change will break your application as well. So you should probably outsource that to somebody else, a different company. So how can we bring the ease of unit tests into our integration tests? Because those are quick and easy. You test your little chunk of code and you're usually done. So this is where local stack comes in to help you. And in a nutshell, local stack, if you're not, are you familiar with local stack? I should have asked that in the beginning. Okay, that's awesome. Yeah, in a nutshell, local stack is primarily an AWS cloud emulator. It also has an Azure image now and a Snowflake image. So if you're in that sort of thing, you can use it as well. This is how I imagine our CTO in the beginning, where he was fed up with using the real AWS. No, he was actually traveling on a train, so he needed something for that to work on the train. So if you leave this room with anything, this is the salesy slide. I just want to tell you that the reason why local stack was conceived was to enable more efficient development testing loops for your AWS applications. It ships as a container image. Everybody's using containers. You spin it up, you tear it down. It's pretty easy. It supports a lot of services. The most popular ones, I guess, would be the Lambda, the ECS, and EC2 actually. And you can, and since it's a container, you can put it in your pipeline, in your CI/CD pipeline, and you have a bunch of advanced collaboration features. There's also a cloud platform. I think every tool has something similar these days, where people share different aspects of your application with your team. And of course, it extends into different things like security testing, and you can build your own extension to that. You can try out some chaos engineering, and so on and so forth. So how much reality can you have in your tests? So with local stack, you would be like here. And I think that's the sweet spot to be in, because that's like the next best thing after the real AWS. You could do service emulation on your machine, like you spin up by Postgres database, or I don't know, any other service, like Elasticsearch, but you have to manage that by yourself. And mocking, obviously, in this case, it's not great to be on this public because the surface is not that great. So I'll show you some stuff. The time is limited for a demo. I wanted to show you this application. Quick review. I'm going to be using some AWS services. These already exist. The DynamoDB, the S3, Lambda, SNS, and SQS services. I already am using Terraform in my AWS account just to save us some time. But the workflow is that our application will add some pictures for some shipments and they will get updated in the AWS services. So I'm going to show you two different scenarios. This is a Spring Boot application, but it doesn't matter so much. You can have this in whatever language you want. We're going to be using production for the real AWS, and we're going to call the development environment. The second scenario should be the other way around. And we're going to be using local stack. And this is what happened in the background, actually. Before I got here, I used the same Terraform configuration script to create these resources on AWS and on local stack. It doesn't matter. Okay. So let's run this application quick so I can show you. Should I switch this to a LiDAR?
Oh God.
Okay. This better? Okay. Some Zoom stuff in the way. I need to make sure. There are good. Okay. So my front-end application is already running. I need to start the backend. My Terraform tab is here with all the resources that run on AWS. So let's start the production environment. And I generated some bucket names. I just need to check that they are correct. This is for AWS. Throw in the bucket names and going to tell it to use the production environment. So my backend application is starting using these configurations. So the endpoint is the real AWS endpoints for these resources that I've mentioned in the diagram. And let's go to our front end part. This is our application. So much Zoom stuff in the way. Let's refresh it. Okay, so I ran a first check at home. We're going to be using Banana for Scale International Internet Measuring System for our shipments. We're going to add an image here, and this will go to the S3 bucket that will trigger a Lambda function. The Lambda function will add the watermark on the picture. It's going to come back through the queue, and it will use server-sent events to update the front end. It's very complex, obviously. It refreshes everything, but the banner is there, so the Lambda functioned correctly. Let's try a different. Oh no, it's the television again. It doesn't matter. It's mostly about the behavior. I can delete these elements, and that's my complex application. Okay, so this is running on AWS. Okay, I don't have time to sign in again. I wanted to show you that all these things are in my DynamoDB table, but I think we need to move on. Okay, there's also an error here, but that's not our main concern here. And on the other hand, I have my local stack container running here. You can see it's just a regular container. I started that. I created the resources here in a second tab, but they're basically the same resources. And you can start our backend application with the dev environment configuration, and it will read these endpoints here, which will point to the. Sorry, I forgot to change the bucket names.
You listen to all.
We have different bucket names for the local stack environment. That should work. Otherwise, it's going to tell me that the bucket that I gave it will not be found. Okay. So again, I tried this before. See, it's a different image, but we can try the banana on a scale for scale, that it works exactly as we expected it to behave. Oh, so it works as expected. And all of this is running in my local container. There's some error here, but let's check on the container. You can see in the logs that everything worked as expected. So now that once I kill the container, all the resources will be gone. Okay. So with this in mind, you can see that the parity is very high. So let's talk about those integration tests because we don't have a lot of time left. Are you familiar with test containers?
No.
Okay, so test containers is a programming framework and supports a lot of programming languages that basically spins up containers, and it partners with a lot of services as modules. So test containers will spin up a local stack container. You can write tests. You run the tests against the test container, and then it shuts it down. Like you don't have to do anything. You just define it and it will do the thing. So like I said, you have a wide array of supported languages. And what are some of the approaches that we use to test our apps? So the first one is my app changes frequently example, which we just saw. You have your local application, it's running on your machine, and you want your workflows, right? You want to make sure that the stuff gets stored in the DynamoDB database, that the Lambda function works as expected. In this case, you'll use a hash on the image, that the pictures are stored in your S3 bucket, and so on. And your app will run against the container. So when you start the test, you also start up the application, the container starts up, and they will just communicate with each other. And then there's the second scenario where you say, my app is pretty much ready. I package it. I can deploy it to an AWS service. This is the example that I used in this case. It's not the same application. I will share it with you. It's using Postman here. But you can use curl or any other HTTP clients. So you can see in this case, we want to test the Lambda function that's running in the Lambda service. We want to make sure that, again, the post calls are working as expected. And your tests will revolve around an HTTP client, and it will look like this, where you define an HTTP GET request, and you execute it in your tests through programmatically through an HTTP client. So your application runs inside the container in this case. So here are my tips and tricks. So there are several ways to provision your infrastructure when you're using local stack with test containers. The first one would be that you provision everything yourself programmatically using AWS SDKs. That's pretty straightforward. It would look something like this, where you use, like in this example, an SNS client. And there's no creation happening in this snippet, I think, but you get the gist of it. It has all the methods that you can interact with AWS services. You can also use init hooks. So local stack has 4 lifecycle events, and these are basically folders where you put in scripts that will get executed when these lifecycle events happen. And it supports AWS CLI scripts with init hooks. And this is classic AWS CLI, except in this case, it uses AWS local, which is the same thing, but it has an endpoint definition that just points to your container. And the second thing it can support is Terraform configuration file, which can also be done by init hooks. So you can put your Terraform configuration file in one of these in the start folder, obviously, and it will run. So programmatically in your tests, you define your container like this. So you just use the library, everything in your chosen programming language, everything is already defined for you. You just say you want a new local stack container. You tell it what extension to install, and then you just give it the Terraform folder and you specify the path, and that's it. So local stack cloud pods, these are basically like a snapshot. If you're familiar with database snapshots, that's pretty much what cloud pods are. I know the naming is not great. They look something like this. You can either, so this is your container, you can save it locally, this is your machine, or you can save them to the cloud and access them, pull them from the cloud whenever you want. So locally, it looks something like this, where you do local stack state import on your terminal using the CLI tool, and you will save zip file basically. Or if you want to use them in your tests from the cloud, just them. Did I do here? Oh, you tell them the path, and it will go also into a init hook folder that's special for pod, and it will start up using this image or this snapshot, basically. The only thing is that you need to use the same major version that you used to create them with. So, for example, if you're only 3, you need to run 3 when you inject the snapshot into your instance. Or, like I said, you can download it on the fly from the cloud, and you give it an environment variable, auto load pod. This was at DevNexus 1 month ago, but this is how it looks. And you can use a mix of all of the above, obviously. So in your tests, how would you interact with your container? Using the AWS SDK, obviously. And it looks something like this. You use, for in this example, a DynamoDB client to get an item, or you can use an S3 client to get an object. And you make sure that the object or the item is suffering the exact changes that you expected to have. Or you can use the AWS CLI commands. You can also pass those to your container. Test containers provide an execute in container method. So you can just write your CLI command as you would in your terminal, and it will execute it in the container. So what about the testing in CI? Because you can also do it in a nutshell, it looks like this, where you push your code to GitHub or wherever you store it, and you'll have a CI runner that will just pull that code, and you define the exact same tests for CI as you would for local. That's it. There's no rocket science behind it. Now let's go. This is how your tests would look locally. I don't attempt to do that live anymore because local stack will pull some dependencies when it starts, and Wi-Fi is always sketchy in offices. But in your CI pipeline, it looks something like this. This is a GitHub action, and you can see you have test run 7, and they were all successful. And I'm going to share that project with the slides. So if you want to test it out yourself, you can give it a try. Some more tips and tricks. Okay, we have 1 minute left. There is a waiter that you can use with test containers to make sure that your Lambda functions are in state active. If you're familiar with it, the Lambda function will go through multiple stages before it becomes available to take requests and run your code. So it needs to be in state active and not pending. Otherwise, if it starts too fast, the tests will fail. And you can do this by using a Lambda client waiter. And you can tell it, wait until function is active, and you give it the get request for the function. And you're looking for this here. Is active. Okay, so you can wait for the container logs to tell you when to start so that your instance is in the right state for your tests. And you use this method, wait for, and this is the message that you're needing for permanent container names. You can also stream your container logs. This is pretty Java specific to your terminal when you run your tests. We're done in 1 minute, I promise. The test containers provides a log consumer to image your logger. Thank you. So you define your logger, the consumer takes the logger, and it will stream out to your terminal where you're running your tests. And lastly, shutting down your Lambda containers finally works because it didn't used to work properly. And it's one environment variable because local stack will spin up separate containers to run Lambda functions and those using a separate image. So previously we had an issue that those would not terminate along with everything. Yeah, and we're getting close to the end. I just wanted to mention that there are a ton of configuration flags that you can use to pass values, pass files, do everything you want with this container so that it runs as expected and your AWS services run the way you intend them to. And that's it.